So last week, what we have done, we have a little bit learned about while loops, if condition, and all those stuff. So for loop, as I told you, a traditional for loop is like different from the for loop in the case of Python. So if there are like collections, okay, from the collection, if there are like 10 values, 1, 2, 3, 4, 5, 6. So if I want to display the value, then we are going to use for loop. Okay, for item any variable over here for a in, let's say, a list. Okay, then you can just print a. You can just print a. It will print all the values. So for each item in a collection, if you want to loop through and do whatever you want, okay, we are going to use for loop. We are going to use for loop. So let's say I have a list. So I have a list. In the list, let's say I have 1, 2, 3, 4, 5, 6. Okay. Now, if I want to, okay, loop through each value, if I want to loop through each value, then you're going to say for meaningful name rather than this. Okay. So if I want to loop through each item, you can say item, you can say a whatever you would like to in the list, then you're going to do this. Then you can do print item. Print item. It will loop through all the values. It will loop through all the values. Okay. If there is a text, if there is a text, then it is going to print. If you could see over here, if there is a text that is defined, it will print all the, okay, each letter in the text. It will print each letter in the text like this. Python program. It will go to each letter and it will print. So like this, it's going to display the case of for loop. It's going to display the case of for loop. But I told you for dictionary, for dictionary we have keys and values. So how we are going to display keys and values using for loop in the dictionary. So we need to operate on both. We need to operate on both. Let's say in a dictionary, I have a key, I have a value, key, value. Now, if I want to display, okay, if I want to display keys and values, so you are going to say dictionary dot items and then display key or value. So you have to define two items now. One for the key for, okay, key, let's say key comma value. These are the two, one for the key, another for the value. In, I need to define this dictionary. Then I will to display both of them. I will be able to, if you define both, then I can display both of them. I can display both of them. Okay. Here I'm going to, let's say, print, okay, key, then it will only print key. If you print value, if you want to print both, print keys and values, then it is going to, one second. If you want to both print keys and values, then you are going to print keys and values. If you want to print values also, you can. Okay. So in the case of dictionary, you are going to operate both of them differently. You are going to operate both of them differently. What if I don't want to just write like that? I want to, okay, I want to operate it in a different way. I want to operate it in a different way. Then you can define the dictionary, and then what you are supposed to do, you have to use the, okay, you have to use the location. You have to use the index in that particular dictionary. Let's say if I'm going to operate in the dictionary that is defined above, okay, this particular dictionary, then what I'm supposed to do, okay, then what I'm supposed to do, then if I want to print key, if I want to print key, then I can just say a, then it will print key. If I want to print value, then I need to say, okay, this dict of A, this dict of A, then it will print the value in that particular key. It will print the value in that particular. Okay. Like this, we can operate on key value pairs. We can operate on key value pairs. Okay. So if it is a normal item, you are going to just define one variable, one item. If it is key value pair, you are going to define two items. Otherwise, you are just going to use the index of that particular key. Okay. Any questions anybody having in the case of
Sir,
for loop? Yeah, please.
yeah, what if you
Please.
want to uh, display only the third value? I mean, 2021.
If you want to display only 2021, then you are going to, so let's say if you want to display only 2021, here, one second. It should work dt of key, but should work, but yes, it is some. Anyhow, I will come back on this, guys. I'm sorry, I'm not able to display over here. I'm sorry for this, but it should.
Yeah,
This
yeah.
is the way normally. Yeah,
Okay.
tell.
So what I thought indexing is maybe suppose you have
Hmm.
one, two, three, four dictionary items
Hmm.
in which where you will be calling third one or fourth one, and you will
You
be
mean
printing that. Yeah.
it will not print? I will come back on this. I think it should
Okay.
be just this dictionary of year. If you do, it should work like ideally. But yeah, that's how it is. This, I'm sorry, I think I didn't use the right word, but this is the way you should print. I was using double quotes, but it's a single quote. This is the way we do normally. So instead of telling the value like location, whenever you use list, then it is going to be indexed like 0, 1, 2, 3, 4. But whenever we say key value pair, it is always key like this text of key. If you do, then it works. That's We have seen the other day also. If you say key value, it's always the key you are going to mention.
So here, so
Otherwise, it
2019, 2019 is not getting printed because it has been overwritten by 2021.
by the 2021. Yes.
Okay.
Let's say if I change this, then if I do my this, then it should work. It does not. Because I just changed the case from Y
Yeah, yeah,
caps,
yeah.
Y
Got it.
small
Got
to
it.
Y caps. Yeah.
Thank you.
So functions actually. So apart from this, there are two other important topics. One is the function. Okay, function, basically why we use a function. Okay, it's a piece of code. It's a piece of code. Okay, which you are going to use, which you are going to reuse. Okay, so normally whenever you say procedure or a function in the SQL, it is the same piece of code which is which you are going to reuse. You define the function, and then you are going to reuse it again and again and again. However you want, you are going to reuse. Okay, so in the case of Python also we have functions. It is very simple. You are going to say def. Okay, means you are defining a function. You can give any name. Let's say sum of numbers. Okay, and then you can pass any number of parameters, a, b, c, d, whatever you can pass. Okay, let's say I will take only two parameters, two arguments to this particular function. Then you are going to say a return, or you can define another variable. Let's say c is equal to a plus. This is what I want to do. Then you can return say, then you can return say, then it will return the value. If you don't return also, it's fine. There is no issue. Now, some people say, I don't want to do this. I just want to do over here. You can do like this. You can do like this. Okay. So nowadays, what people are doing in the interview. Okay. Now, if you want to call this particular, so first what we are going to do, you are going to define sum of numbers, then a comma b. You are not going to define any data type. Okay. Then you are going to do the return. Now, in this, what if I assign 10 over here? What if I assign 10 over here? Then if I do return, okay, a return of a plus b, return of a plus b. So whenever you are calling a function, you just use the function name. You just use the function name and pass values. I want to take sum of 10 comma 10. Fine. It will give the sum. It will give the sum. Now, if you look at the below function, then here, if I do sum of numbers, then if I just pass 10, okay, will it work? If I just pass 10, will it work? Okay, anybody who knows Python, they can answer.
No, it won't.
It will work. Why it will work? Because you have defined a default value. You have defined a default value. Okay, that's why it will work. If you don't have a default value, it won't work. Absolutely correct. If you have a default value, it won't work. Okay, it will work. If you don't have a default value, it won't. Okay. Now, if you just call this function sum of numbers of 10 has here I written, then it will return again. It will return again 20. Return again 20. Okay. So if you want to override, then you can pass. This will override this value. No problem. Override means this will take the preference than the value defined over. Than the value defined over. Then it it will give 30 as the result. It will give 30 as the result with the sum. Okay, let's say, as I told you, let's say I want to I want to create, like, let's say I will create a function. Okay, sum of numbers. Okay. Now, as I told you, let's say I will pass two arguments, a comma b. Now, if I okay, if I return, okay, a plus return a plus b. Okay. Now, if I call this particular function, let's say, okay, if I call this particular function, first I need to run this, okay, then I need to call this particular function. I need to always run this because otherwise it won't work. Sum of numbers, then I give 10 comma 20, 10 comma 20. It should result somewhere. It will result 30. As I told you, if I define a default value, Okay, let's say 10. If I define a default value, let's say 10. Okay, now if I run this, if I just pass 10, it should give the it should give the okay. In the code snippets, people are asking this. Just be aware of this. Just be aware of this. Okay, this is, I'm not saying it is too tough. You are going to do write some logic which you are going to use. You are going to write some logic which you are going to use. That's the simplest way of explaining a function. Simplest way of explaining a function. Okay, but in the case of function, whenever we define, there is something called as a global variable. We have seen a variable. Okay, just define a variable. Okay, a is equal to 10, and I can reuse anywhere. Okay, anywhere over here. Whenever we define something inside a function. Okay, whenever we define something inside a function, let's say a is equal to b. Here, what I will do, c is equal to 10. I will just do this. Okay. Here, why I define a variable inside this. Can I use this variable outside? Okay. Can I use this variable outside? Let's say I will just do, okay, I will call this particular first function so that it will execute that function. Then I will see whether I can use C outside. This has executed, it is returning some value. Now, if I print C, if I print C, okay, it will say undefined. Okay, it is not defined. What if a variable defined inside a function I want to use? Somebody execute this particular function. Once they execute this particular function, then a variable defined in that function I want to reuse. Can I do that? Can I? Can I reuse a variable, okay, defined in a function? Defined in a function. Okay. Then I would say there is a way you have to use the keyword global. You have to use the keyword global, then I can reuse. If I define it with keyword global, let's say, then I need to just okay, if I define with keyword global, I cannot assign the value until I define. So then I can reuse it. Then I can use it outside. Now, if I do, I need to execute the function. Without that, it won't work. I need to execute the function. Now, if I use this C, then it would work. Now I can use this. So just remember this. Just remember this. Basically, sometimes you execute this. Okay, you execute the function and define a variable, and you can use that. Some people tend to use. Okay, so this will become handy. Just see if they have defined it as a global. As a global. Otherwise, you cannot use. Otherwise, you cannot use. Okay, any questions in this case? Any question in this? Because these two, the default value and then this global, these two, they ask in the okay, hacker ranking, not interviewer will not ask. Okay, hacker ranking test. Okay, so that it will be helpful. I just highlight whenever there is a where I feel it is a interview question. I just highlight. Just think about it. You will get a lot of good
Hi,
questions in interview.
hi,
Okay,
Bharat.
please, please.
So here you mentioned A, B, right, as a parameters.
Yeah,
So
yeah, yes,
can
yes.
you pass the values from the A, comma B dynamical?
So A comma B dynamically you can pass. You can pass A comma B. You can define a list and then you can pass A comma B to this particular thing. You can define a
Here,
list. Let's say, for example, if you define a list, okay. Let's say if you want to define a list, you can define a list like this, and then 1, 2, 3, 4, 5, and then you can do for item in list. Then here you can pass this item can be passed as a, let's say, sum of item comma 10 if you do. Okay, then it should print the value. There is no issue. Like sum of numbers, what I said. It should work. You can dynamically do this. Means dynamically is something you are going to define. It is not that it will do by itself, right? You have to do it. You has
No,
a
no,
yeah.
I'm asking in the first
Hmm.
scenario, we hard coded the value c equal to 10, right?
Yes.
So what I'm saying is, like in which scenarios it will work? Like which we hard coded. So normally it will come from variables, right? Whether it should be a comma b.
See, it will be be like a plus b a something. You are going to do some logic.
Okay.
Okay. While teaching, I am going to do a hypothetical example. It is not that. See, this is some logic. Whatever logic you can go, a plus b plus a plus b plus. You can do whatever you would like. There is nothing as such. Hard coded. See, if there is a variable, you can generate it from other variables, or you can generate. You can do a hard coding. Whatever you would like to do, you can do. There
Okay.
is no issue. Okay.
Got it.
Yeah.
Got it.
Yeah. No.
I will.
Please
Yeah. Is there
go
any
ahead.
predefined functions are available or all are?
See, libraries will be there. Lot of libraries will be. Uh, libraries will be there. We'll have to import those libraries. Okay, import from PySpark, mainly with the PySpark. From PySpark, we are going to do SQL functions. We are going to do SQL functions and SQL types. All the time we are going to import and use them. Because data frames are created based on the uh, like SQL functions. Though, so somebody is going to define the function and then register them, then you can use. Then you can use.
Okay.
I will
So if
show
we
that.
have any,
Yeah, please continue.
okay. If
If
we
you
have
have,
any custom one also, we can register to our own library.
yes, we can
That is
register
what
to
we.
our own library. Yes, because
Okay.
sometimes what happens in office also, we will find it easy to write logic in Python. Okay, and we'll register them. Okay, then we'll use SQL. In the SQL, I want to use the function. Then I'm going to reuse that particular function. I'll show that while learning SQL. I will show that how to
Yeah. So
reuse.
importing
But
and
yeah, we
exporting
took this.
also it is possible throughout the cross-platform between the servers.
So we can do that. There are some different ways where you can register the libraries, importing the libraries, and that is possible. People
Okay.
does it. There is no issue. Yeah. So whenever it comes to programming, this is no different. It is like other programming.
Okay. Okay.
Okay, fine. There is one thing called as lambda function. How many of you have heard about lambda function? Anybody heard about lambda function? Okay. So whoever is having an idea, they can tell me. It's okay. Otherwise, it's okay. There is. I don't want to. I just wanted to know whether anybody knows. So lambda function. What happened whenever they created PySpark? Okay. Whenever this PySpark was created. Okay. Then they have introduced something called as RDDs. Okay, RDDs are resilient distributed data set. Okay, this RDDs, like it is similar to data frame. It is similar to data frame. We'll understand what is data frame and RDD. Okay, this RDDs won't work without functions. Without functions. Okay, small logic also I want to do. I need to use function. So I cannot go on creating functions just for doing the small logic. It will hurt. It will always hurt. Okay, because I should be. It should be reusable. It should be because people may question why you are creating so many. So instead of that, okay, they have introduced something called as a lambda functions. They introduced something called as a lambda functions. Okay. So what is a lambda function? Okay. In the case of lambda function, what happens? You are going to define, okay, you are going to define a variable, let's say a is equal to, you are going to use lambda. Okay, it's a instant instant function that is created. Okay, you can pass variables like x and y. Okay, I want to take sum of these two, then I have to write the logic in the same line. Okay, if at all, if you define a lambda function, okay, and if you try to write in another line, that won't work. Any expression after the lambda, you are going to just, okay, you are going to just define the logic in a same line. As soon as you give the colon, okay, lambda, okay, as soon as you give the colon, if you pass the arguments, as soon as you give the colon, you have to define the logic. You have to define the logic. Otherwise, it won't work. Otherwise, it won't. Okay. So this is similar to function. It is not like there is no too much of difference. It is similar to function. Okay. Now, if you want to call this particular function, then you are going to say a of x comma a of x comma y. Okay. So this particular thing, how we are going to reuse, it is only useful with the RDDs. You are not going to use it with other function. You are not not going to use it with other things. Okay, only with RDDs you are going to use. Only with RDDs you are going to use. Okay, just okay. This can, you may not use also. Now everyone is using data frame. 100% of the time people are using data frame. You may not use also, but people should know what is lambda function, because sometimes if you use R, then it will come handy. You need to know. Even interviewers also, they will ask what is lambda function. So as I told you, whenever you want to use a lambda function, you can define a variable, let's say a, then keyword lambda. Okay, you can pass two arguments, then you have to write expression in the same line. You cannot go somewhere and write again. You cannot go somewhere and write again. So you can just pass 10 comma 20 like this. Okay, lambda function, it will be really handy. You don't want to define any object, okay, but you want to use it as soon as it is defined, and it will come handy with RDDs. RDDs won't work without lambda function. So without function, okay, lambda is another function. Lambda is another type of the function. Just you need to remember this. Just you need to remember this. So if you check the type of this variable a, then it will say whether it is a function or it is. This will definitely come handy only with RDDs. It is important to some extent, but yeah, you may not come across at all, I would say. I have not used in the real time. Okay. So any questions anybody having in the Lambda, guys? Okay. Let's see exception. So whenever we write any program, actually, whenever we do any coding in a programming language, okay, so we will come across a lot of errors. It's a it's a normal thing. It's a normal thing. Now, people will ask you, how will have you done error handling? Okay, have you done error handling? Okay, how you have done? How you have done? Okay, in the case of Python, okay, we are going to use something called as a try exception. Try exception. In the case of SQL, traditional SQL, you are going to use try catch blocks. Try catch blocks means I want to try something in the try block. I want to execute some code. Okay. If it throws an error, I want to catch. I want to catch the exception. I want to catch the exception. In the exception, I'm going to print system exception, or some good programmers, what they will do, they will create n number of exceptions like this. Okay, one, two, three. So they would know what exactly is going to be the error that they may face, and then they will define the exception. They will define the exception. Let's say if it is divide by zero error, if you are doing a numerical operations, so you may face divide by zero error. They may define divide by zero error. If it is other than that, then they will have another exception. You can go on defining any number of exceptions like this. Okay. So what you are going to do in the try catch or try exception block, you are going to try the code. If the code is successful, it will never go to exception. It will never go to exception. Okay. So if you want to know whether try exception block is executed, people use something called as a finally. People use something called as a finally. If try is executed, also exception is executed also. Means if try executes, if there is issue in exception, it will go. And finally, if you want to say try exception is completed, then just while debugging purpose, you can use, yeah, try exception is completed. You can use something called as a final. Okay. So whenever you define, let's say I have a is equal to a is equal to 5, b is equal to 0. Now I want to try some code. I want to try some code. Okay. Now if I want to try some code, I need to use try exception. Okay. Try exception blocks. Then how we're going to do this? Okay. So you would have come across different kinds of try catch block. You would have done exception handling in a different way in other languages. So any code which you want to execute, most of the times every code block will be in the try exception. Every code block. Okay. Now if I do C is equal to A slash B, C is equal to A slash B. Okay. Then if at all, if it executes properly, then I'll say C A is division is complete. Let's say division is successful. Division is successful. If it is erroring out, then I am going to do exception. I'm going to do the exception. So in the exception, you are going to print any exception. If you want to take the, okay, if you want to take the system system error also, you can take the system error. So whenever you are like defining the exception, uh, you have to define an object of type. If you have to define an object of type E, then it will actually catch the error. You can just do E over here. You can just print over. Okay, then it will throw an error. It will throw an error. Okay. Now, if at all, if it is successful, let's say, then it will just print division is successful. It won't go to the exception. Don't go to the exception. As I told you, if you want to do finally, you can say, you can do this finally also. You can do this finally also, right? Okay. The division is complete. Let's say anything you would like to, anything you would like to. So you need to know. So some people, what they will do, very good programmers, they will know if at all if it is a divide by zero exception, they will know it is a divide by zero exception. They will catch it. If it is other than divide by zero exception, they will define another exception like this, and then they will print the system error. They will print the system error. You need to be, so let's say here in this particular thing, if I want to call this divide by zero function, okay. Now if I say, okay, div by 0, I will pass 10 comma 0, then it will throw divide by 0 exception only. If it is not, then we'll see what it 10 by 0, then it will throw divide by 0 exception. If I pass a text, Okay, then should throw some other exception. Unsupported operand type slash integer and string. It's a system exception. It's a system. So I normally use this only. I don't define too many except blocks. Okay. But if you go to like product companies, then they will, okay, then they will normally do define error like this because they want to exactly know and fix it right there. Then they will do this. They will do this. It's all depends on which use case. Applications, they will define the errors. They will define exceptions like this so that it will be easy for them to fix it as and when they want. Okay. Any questions anybody having? We're going to use them heavily. Okay. Every code snippet, if at all, if you, I will just show you some sample. Okay. If at all any code snippet that you are going to do, it will be in the try exception block only. It will be in the try exception. You won't see, you will see very less wherever there is a variable defined under. Only those code blocks you won't see this try exception blocks. But other than everywhere you are going to have, whenever you are trying something, then definitely you are going to use the try exception. Anybody got any question? Please ask me. Actually, okay. In this particular notebook, I just show you every cell we are going to use try exception like this. Just we are going to use try exception. We are going to use try exception everywhere. If you could see try except, try except, try except. Okay, this will be helpful for us. This will be helpful. Okay, normally whenever you want a code block to fail, we'll use the raise. Raise will make the, okay, in the try except. Okay, some projects what people will do, they want to fail that particular cell so that they can go and fix it. After printing or after logging, they will just do the raise. They will just do the raise so that it'll, that code block will be failed and then people will fix. People will fix. Just remember this. Any questions anybody having? Please ask me in the try exception. Hello. Okay. Even you can, if you don't want this, if you raise, it will stay up. It will be helpful. It will be helpful for us. Okay. It is 0. So, okay. Raise means if you see you want to make it fail and no other cells to be executed, you are going to use raise. Okay, any questions anybody having? Please ask me. Otherwise, I will go ahead with the next. So, I wanted to cover limited topics in the case of, okay, in the case of Python. Okay, as and when we come across little other things, we'll see. But basically, you need to know like looping, you need to know collections, you need to know exception handling, you need to know how to define the functions. These are the main things. These are the main things in Python. These are the main things in Python. There are other things like reading a file in Python. Okay, reading a file in Python. Okay, so reading a file in PySpark. Okay, reading a file in Python, it So basically, we all need to remember whenever we are talking about big data, we always talk about data lake. We always talk about the data lake. Okay. Python basically read, it won't read from data lake. Okay. That setup that we have done in the Databricks, like or the Databricks has provided, Python cannot read from the data lake. Okay. Only PySpark can read. PySpark can read from data lake. Okay. So that's why I am avoiding the topic. It is very simple. There is a notebook also. All you are going to do is you are going to, okay, read the file in. There are different modes. I want to read. I want to write. Okay. So whenever you read the file in Python, you can read in the mode, read mode, R mode. If you want to write, you are going to do in the W mode. Okay. So we have notebooks also, we can say if you want, but I would say we are going to, let's do it with PySpark. That will be good. We never ever going to read anything using the Python. Never ever, because we're always talk about the big data. We are never ever going to read something using the Python actually. So there is a notebook that is already given also. If you want, I can go through that. If you wish, you just tell me. Okay, some people are told like I'm covering some topics which is easy, they know also. But I want to know, if you guys want to know, I will cover that. Otherwise, I will start teaching how the setup is. Like we'll start with the Spark SQL, how it works, things works in Spark SQL, what all things we need to know. We'll start with the Spark SQL. And also, I would like to know, like anybody is having data warehousing background, or you guys want me to cover data warehousing concepts? I want to know that. How many of you want me to cover data warehousing concepts? Please let me know. Anybody wants me to cover data warehousing concepts? Don't hesitate.
Yes,
It may take one class extra. Sure. How many
yes, please.
other? Yeah, even one person. Cool. Sure. I will cover data warehousing concepts. Okay. Now, before covering the data warehousing concepts, two things we need to understand. Okay. So, in the case of PySpark, okay, PySpark, it uses, can you please mute whoever's spoken just now? Please mute. It is causing some disturbance. Okay. Whenever we talk about Spark SQL, okay, in the backend, we have two different things. One is, okay, one is data, another one is metadata. Okay, whenever we talk about Spark SQL, we have two things. One is data and another one is metadata. Data means, let's say I have an Excel file like this, for example. Okay, I have data over here in this particular Excel file. Let's say I have ID. Okay, I have name. I have ID, I have name. Okay, in the ID, I have one, two, like name, let's say we know. Okay, two, let's say such. Okay, so this particular thing that is available inside this sheet is data. Okay, what is metadata? What is metadata? Okay, now ID, okay, Excel sheet name, Excel sheet name, sample. Okay, now in that, okay, what is the column name? Okay, what is the different column names? What are those data types? Okay, these are the metadata. Column names, data types, and if it is allowing any constraints, if it is allowing any constraints like null, not null, primary key, foreign key. Okay, these are the different constraints. A thing which stores all of this, a thing which stores all of this is called metadata. Is called metadata. It is data about data, data about data. Okay, metadata is data about data. Metadata is defining a table. Okay, column types. Okay, defining the table number of columns, column names, all these things will become the metadata. All these things will become the metadata. And also whether it allows, it is having, it supports any constraints or not. Okay, so in the case of data, in the case of metadata, data is all about. So in the big data world, in the big data world, data is separate and metadata is separate. Okay, data will be stored in a file system. Data will be stored in a file system. So if I create a table, if I create a table, what it does, it will create a folder. It will create a folder. Okay, if I load the table, then it will create a file. It will create a file. Create a table will create a folder. If I load the data, then it will create a file. Then it will create a file. How about database? How about database? What is a database? What is a database? So in the case of database, if you take the traditional SQL, you will have different schemas. If you will have different schemas. Let's say database, let's say finance. In the case of finance, we have, let's say, general ledger. We have, let's say, accounts payable. Okay, accounts receivable. Okay, all these are different, okay, subject areas. So what we'll do for these things, we'll create different schemas. But in the case of big data, okay, database and schemas means the same, means the same. It is no different. It is no different. So if at all, if there is a table in the traditional database, what we'll do, we'll have a database name, as I told you here, finance and AR, okay, then table name. Let's say it is transaction. But in the case of big data, you cannot go three namespaces. Three namespaces. Namespaces means three things appear in this particular name. This is database name. This is schema name. This is table name. In the case of big data, it will be only two namespaces. Two namespaces. It will be, you can define in a different way. Fin underscore AR, then the transaction, then the transaction. Okay, then you can question me, why don't people create the same way over here? Okay, time and again people reinvent new things. Okay, so it was allowed, then the people have created different way. Okay, here it is not allowed, then you are going to define database or schema. Create database. Okay, database name anything like finance, fin underscore AR, or create schema, fin underscore AR means same. Both means same. Both means same. There is no difference. There is no difference. You need to understand this. There is no difference. Okay. Creating a database will create a folder. Creating a table will create folder. Loading data will create a file inside table folder. Inside table folder. We'll see in the coming classes. But you need to have this understanding. You need to have this understanding. Okay. So we can control over here. What we can control? Whenever I want to drop a table, then I can just drop metadata. Data can still be there, still be there. Look at the flexibility that big data is giving us. Okay, that's why they're operating different. Data is different, metadata is different. Data is different and metadata is different. We can drop a table, but I can still keep the data. Metadata will be gone, but data will be there. Data will be because it's all about folders. Inside a folder, I have a file. I need to protect this file, but I want to drop the metadata. I want to drop it. That is also possible in the case of case of, okay. So now, whenever we talk about big data, okay, whenever we talk about big data, it's a distributed computing system. See, actually, whenever we start Spark SQL, okay, so I need to start talking about the big data concepts. People think he's talking something very easy. It's a mix and match. Some things you would know, some things you don't know. So you need to understand, okay, people, why people will teach. Some people are saying like I'm teaching basic. Basics are needed some, basics are not needed some. Okay. So you need to understand. Some people may not know distributed computing. Some people may know distributed. Now let's say we are talking about distributed computing. So in the case of distributed computing, okay, let's say there are 10,000 rows. I want to load 10,000 rows. Now this is a master. These are all slave nodes or a child nodes. Child. Now it will split the data. 2,000 rows here. Okay. 2,000 rows here. 2,000 rows here. Okay. Like that, every node it will load 2,000 rows. Fine. It's absolutely fine. Okay. Now, whenever we talk about the constraints, whenever we talk about the constraints, primary key. What is a primary key? What is a primary? A column which don't allow null. A column which don't allow null. Okay. And it is unique. It is. So if that is the case, then it will be called as a primary. Which don't unique means every row it is different. Every row in that particular column is different. Okay. If that is the case, then it becomes a primary key. Since this is a distributed computing, in the case of Spark SQL, it is a distributed computing. Okay. If I create a column, let's say I create table, table name, let's say table one, ID, integer. Okay. Here, I cannot create a primary key on this particular column because it is a distributed computing. I need to go into this particular, okay, storage location, check. I need to go in this particular location and check every location I need to go and check. Okay, to see whether there is that row that you are trying to insert is already available. It will be a biggest problem. It will be, instead of solving the big data problem, big data is a problem. It got a lot of data. So instead of helping to do the distributed computing and processing, we're taking an additional overhead of checking data, okay, checking data in every disk. This is a problem. You should not be doing that. That's why it don't support primary. It don't support primary. It cannot go and verify in every disk because I have done 10 partitions. If I have billions of rows, then I will have thousands of partition. Can I go to thousands of partition and check whether a row is particularly inserted, whether it is unique or not? Then how will you ensure it is just logical? Primary key, you should, developer should know it is just logical primary in the case of big data, any big data platform. Snowflake also, it stores the data. You can create in Snowflake with primary key. Here I can say primary key, but it does not enforce. It cannot verify. It does not enforce because it is also a distributed computing. You are splitting the data and storing it to multiple places. Then you cannot go to each place and verify whether that any unique row is available or not. Null can be done because while inserting, if you say not null, then it can be enforced. It can be enforced. You don't need to go to disk to check the null. But unique, you need to go to disk. So that's why primary key is just logical in the case of big data work. You take This also you take Snowflake also. It is the same. It is the same. Whoever follows distributed computing, primary key won't work. Now people can tell me whether foreign key is supported or not. Take a chance and tell me. There is no issue. We'll sometimes need to discuss. I need to gauge the whether I am telling conveying the message right or not, so that I can repeat. Can is foreign key supported in the case of big data tables? Can somebody please take chance and let me know? Hello. Since it is a distributed computing, if primary key is not there, there will be no foreign key. There will be no foreign key because foreign key is always depend on the primary. Foreign key is always depend on the primary key. Even okay, even let's say if it primary key is supported, then if you want to enforce foreign key also, all the shufflings will happen again. Data should shuffle. Okay, data will move from one disk to another disk and it will cause a lot of issues. So foreign key is also not supported. Foreign key is also not supported. Okay, these two very important constraints are not supported in the case of big data. In the case of big data, people may question why, because data is distributed and you cannot go to every partition and enforce it. That's why. That's the reason. That's the reason. Okay. There are different constraints. Primary key, foreign key, okay, null, not null, check constraints. Check constraint. Now, there is a identity constraint. There is a identity. What does identity constraint do in a traditional SQL? Okay. Let's say if I create a table, create table one, okay, ID, okay, int identity 1 comma 1. Okay. Now I can it is supported to some extent in case of database. It is supported, but it is not matured enough. Why? Because what's happening, if at all, if I try to parallelly load to a same table, parallelly load to a same table, then then identity it will try to generate. Okay, there are 10 of you in the class. Okay, I am trying to load to the same table, you are trying to load to the same table, and if I am trying to generate the identity key along with you, then it will create a problem. It will create a problem. If it is sequential load, then it works. Okay, null, not null, check, identity to some extent is supported. Primary key and foreign key are not supported in the big data world. Okay, please ask me if you not able to understand. Anybody got any questions? Please ask. I'll be covering in data warehouse concepts in depth, but I want to clear this first. So just that's why I started. What are the different constraints? What is supported here? What is not supported? Anybody got any questions? Please ask. Hello. Am I clear in conveying this message?
Uh,
Or
how
you are
can we how can we avoid duplicates?
so logically, so you need to before loading, you need to take care. Before loading, as you need to use like let's say data frame, then you are going to use drop duplicates. If you are using SQL, then you are going to do select distinct. Okay, these kinds of things you need to handle it. You need to handle it as a developer. Otherwise, what happens whenever you are going to use merge don't support duplicate values. Merge in Spark SQL don't support duplicate. So what is merge? It supports insert update both in a single statement. It will throw an error. So we need to handle it logically. We need to verify whether there are unique, there are any uh, null values or duplicate values coming. All these things we need to verify. That's the data quality check we are supposed to do.
So, does it mean the upstream file, if you are having duplicates, we need to
Hmm.
load into some other file by avoiding duplicates, by writing some logic?
Absolutely.
Okay.
Absolutely. You will read into a data frame and then you are going to select the distinct values or you are going to do the drop duplicates and then take it further.
Got it.
Yeah. Okay. So this is the basics that we started. Tomorrow also I'll be covering a lot of concepts like uh, different data warehousing concepts that I'm going to cover. Even though we are in the like big data world, traditional things is also being used widely. And if you say data engineer, people expect you need to have understanding of the data warehousing concepts. Okay, so I'll be covering in depth again tomorrow. But you need to have this understanding of primary, foreign key, these things. So I started with this. Tomorrow also, like in depth, I will cover the data warehousing completely. If you want to go through also, okay, there is a material over here. Please, data warehousing concept PDF is there. You can go through PDF just in case if you want. If you feel it is like after my class also, if you want to go through, then also, then also. Right. This is the PPTX. Please go through it once. Data warehousing concepts.
Yeah, I have one more question.
Please.
Yeah, we are using different technologies, right? Python, PySpark, and Spark SQL and Scala. So, in what scenarios we are using this? Like in a particular project, we are using all these technologies, right? Do we have any cheat sheet for that?
So there is cheat. There is nothing as a cheat sheet. Cheat sheet is mainly for code logic that you are going to use. But basically, understanding of Python, Spark SQL, and PySpark is depends on your capability. You will be flipping between PySpark and so data engineering work mainly. Okay, basically what you are supposed to do. So while reading stuff, you are going to use PySpark reading stuff like mix. PySpark is mix of Spark API functions and then the Python. Okay, then while doing the transformations, if you are good at if you are good at SQL, you are going to use the Spark SQL. But if you are good at like PySpark, then you are going to use the PySpark. But basically, I would say, okay, what I do is like while reading the let's say reading file and writing the file, I would use PySpark directly, and in between any like joins or any conditions, lot of transformations, we use the Sparks. We use the Sparks transformation. Okay, you may tend to use PySpark also, if at all, if it is really easy. But transformation logic, because as I told you, we are migrating on-premise solutions to the cloud. If we are migrating on-premise solutions to cloud, you are going to reuse the logic that is already. So you are going to use the Spark SQL.
Okay, good.
Scala, I have not used, yes, just to be frank. Even I don't teach Scala, but yeah, I have not used any time.
What about Python? PySpark we are using for reading and writing. Python.
It is,
Uh,
say, mix and merge, you will say.
okay.
PySpark, Spark is an API. Okay, all the functions you have over here, you are going to use. Python is the core programming you are going to use. Let's say whenever I am saying I am declaring any variables, I am declaring any defining any function, you are going to use Python. You are going to use Python way that we learned the basics. Okay, but you are going to use the Spark inbuilt libraries for making it work. So it will be mix and match. You say ideally it's a PySpark. So exception handling. There is no other way other than Python coding, like try exception to log the error. So that's when the Python, like, it is mix and match. I would say, like, it is not. I cannot give a concrete answer, but you will get it along. You will not feel of much of a difference actually, because anything I want to use distributed, I will always go for a Spark. Big data, data engineering, I would go for a Spark. But if you are using a traditional data analysis or a data science, then people use this Python. People use this.
Okay.
Yeah. You will be using Python to a big extent here also. I'm not saying we don't use, but just the Python, there you will. Okay. Any other question anybody having? Ask me, otherwise we'll continue again with tomorrow.
No, I asked one more question. In case of Rise, right? So if a particular code block is failed,
Hmm.
then the next block will execute automatically, or entire Rise
No,
will
no. If
stop.
you if you put a raise, it will stop right there. It will stop right there. Okay. But you should be careful. Okay. Raise with notebook exit. If you do notebook, there is something called as a notebook, a db will start notebook.exit. We'll see those things. But if you raise with notebook exit, it will actually exit the notebook directly. It will actually exit the notebook. If you don't raise, it will just print, or it will just log and then go to next. Go to next. If you use raise, means either you are going to say I'm going to exit the notebook, or I will make it fail. So in one of the projects, I did this raise notebook exit. People said, no, 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 we want it to fail right there. We will go and fix it. So it's up to, because sometimes you are going to do just the development and then come out. So if they want to maintain, then this is the way they want to do this. Then some other new person came from the customer and he said, why the heck you are doing this race? Why don't you do the clear exit? So you need to make them understand what is helpful, like how they want to handle
Okay. In both the cases, so entire code will be entire
it.
code
Skip
execution will be
next,
stopped. Okay.
skip. Yeah, it will be skip. Okay, fine. Yes, we'll continue tomorrow. Bye for that. Any more questions you can ask, otherwise we'll exit.
Thank you.
Okay, speak out, guys. I would request people to speak out. I think some people hesitate, but don't hesitate. Please speak out. Bye for that.